Hello everyone, welcome to IIT and GATE classes. This is lecture 14 on operating system, and in this lecture we are going to start a very important topic, that is deadlock. Okay, many times question have been asked in GATE, Net and other competitive exams. Okay, this is very important topic. So first of all, let me explain you what exactly is deadlock. See, for example, we have two processes. Let us suppose we have two processes, P1 and P2. Okay, and both needs two resources for completion, that is A and B. So there are two processes, P1 and P2, and both need resources A and B. Okay, so so let me give you some scenario. Okay, so let us suppose P1 is holding resource A and it is waiting for resource B. Okay, there is some scenario which I am making. Okay, and P2 is a process which is holding B and waiting for A. Are you getting it? There are two processes, P1 and P2, and two resources A and B. P1 is holding A and it is waiting for B. P2 is holding B and waiting for A. So P1 is having A and P2 is having B. Both need both the resources for completion. Okay, P1 and P2 need both A and B. But I have made a scenario in which P1 is holding A and waiting for B. P2 is holding B and waiting for A. Okay, so now clearly this is a deadlock kind of situation. That means P1 is waiting for P2, P2 is waiting for P1. This is a deadlock. Okay, so and there are four conditions for deadlock. Let me tell you that also. Take the snapshot. I will jump to the next slide. Okay, so now there are four necessary conditions of deadlock. There are four necessary conditions for deadlock. The very first condition is mutual exclusion. Mutual exclusion means there exists at least one resource. There exists resource which can't be shared. Okay, which can't be shared. So for example, see in the previous slide, see this. So A, if P1 and P2 both can share A, then obviously there will be no deadlock. P1 and P2 can be completed successfully. Okay, so at least one resource should be mutually exclusive. That is what I have written here. There should be a resource which can't be shared, because if A and B can be shared, then no problem at all. Both need, P1 and P2 need A and B, so they will get A and B and they can complete. Okay, but I am assuming that there must be at least one resource which can't be shared. So that is the first necessary condition. Okay, and let us give the second necessary condition. It is hold and wait. Hold and wait. Okay, so you can check it out. See this. P1 is holding A and waiting for B. P2 is holding B and waiting for A. That is hold and wait. Hold and wait means there must be a process must be holding at least one resource and waiting for other. Okay. Processes must be holding one resource, at least one resource. Okay. So I will write it like this: at least one resource and waiting for other. Okay, that is the basic meaning of hold and wait. It is holding one, at least one, and it is waiting for other. That is hold and wait. Next is no preemption. No preemption means, see this, in the previous slide itself I will tell you. See the previous slide. No, see this. If P2 is waiting for A now. If P2 can snatch A from P1, then obviously P2 will get A and B and it can complete its execution. And after completion, A and B will be released and P1 will take B and it can be completed. So the deadlock will not be there. Okay. So if preemption is there, then there will be no deadlock. But I'm saying no preemption. No preemption means P2 cannot snatch resource A from P1 and P1 cannot snatch resource B from P2. That is the basic meaning of no preemption. That means process will voluntarily release the resource. Process must voluntarily means अपनी मर्जी से. Okay, process must voluntarily release resource. Okay, it is not like that one process can preempt resource from other. Okay, it should not be there. Okay, yeah, this is no preemption. And the last is circular wait. Circular wait. So circular wait is simple extension of hold and wait only. Okay. Logical extension of hold and wait, which leads to cycle. Which leads to cycle. See this? So we have a cycle kind of thing now, that is circular weight. So these are the four necessary conditions for deadlock. Necessary means even if all these four conditions are fulfilled, deadlock might not be there. Okay, but if one of them is not fulfilled, then deadlock will never occur. That is the basic meaning of four necessary condition. So let me tell you that also. These four necessary condition means these are necessity. That means these are basic necessity. I think you already know what is necessary and what is sufficient condition. So necessary condition means that even if all these four conditions are satisfied, I'm writing shortcutly. Even if all the four conditions satisfied, deadlock might not be there. Deadlock might not occur. Okay, but if even one of them is not satisfied, if even one of them is not satisfied, then deadlock will never occur. Deadlock never occur. Okay. So you should remember these points very beautifully. There are four necessary conditions for deadlock. Even if one of them is not satisfied, then deadlock will never occur. But even if all these four are satisfied, deadlock might not occur. Okay. So deadlock here I'm using deadlock will never occur, and here I'm saying deadlock might not occur. So I think you have got it. These are the four necessary conditions. For example, see this. Mutual exclusion is not there. That means what? Resources can be shared. If resources can be shared, then obviously they will complete. There will be no deadlock kind of thing here. Similarly, if hold and wait. If hold and wait is not there, that means P1 is holding A, then it cannot request B. Since P1 is holding something, so it cannot request. If I give you that condition, then obviously deadlock will not be there. Okay. Similarly, no preemption. If P2 can snatch A from P1 or P1 can snatch B from P2, then obviously there will be no deadlock. Okay. So if preemption is there, then there will be deadlock will never occur. Similarly, hold and wait is not there, then deadlock will never occur. Mutual exclusion is not there, then deadlock will never occur. Circular weight is not there, deadlock will never occur. But all these four are satisfied, even then I cannot guarantee that deadlock will be there. So I will say deadlock might occur. That is the basic meaning of necessary condition. So I hope you have got the point. Okay. So now without wasting any time, there are many techniques of deadlock handling. Okay. But we will, since it is a basic course, so we will study only one technique, that is deadlock avoidance. Deadlock avoidance. Okay. And it is very important. Many times question have been asked in GATE, NET and other competitive exam. So the very first very simple question asked is that for deadlock avoidance, which algorithm is used? You should know we are going to use Banker's algorithm. Banker's algorithm. Okay. And what is the why we are calling it as Banker's algorithm? Because banking people use this algorithm, use it to manage capital, to manage their capital. Okay. To manage their capital, they are going to use this bankers algorithm only. That's why we are calling it as bankers algorithm. Okay. The word bankers come from banking people only. So I hope you have got it. So let me tell you that how this you can say banking algorithm, bankers algorithm work. Okay. So let me tell you that. So first of all, we should know what are the data structures used for bankers algorithm. Okay. DS used. Okay. So the very first is available. Available M. Available M is 1D array. Okay. And say for example, I will say there are total say A, B and C. There are three resources. And for example, I can take here for A we have 10 instances, and for B we have 5, and for C we have 7 instances. So like A can be printer, so there are total 10 printers available with you. Okay. B might be monitor, so there are 5 monitors and so on. So these are the resources, and these are you can say which are present with us. Okay. Available means what? These are available. So I will say A10, B5 and C7. These are the resources which are available with us. That is the basic meaning of available. Okay. And if some of them are allocated to processes, then obviously available will change. For example, I say that one printer is given to, let us suppose A is printer. Okay. One printer is given to P1. Okay. One printer is given to P2. So now our available will be what? 8, 5, and 7. A, B, and C, because two printers we have already given to some other processes. So available means at particular instant of time, how many resources and of which type are available with us. I think you have got it. Okay, so printer is a device. Okay, and this you can say 10 is the instances. Total 10 instances of printer are available. Similarly, total 5 instances of say monitor and so on. Okay, so these are the available. I hope you have got the point. Available means presently how many instances of which type are available with us. Okay, that is the basic meaning of available. Okay, so this is the first data structure which we are going to use. Take the snapshot. I will jump to the next slide. Okay, don't worry. Yeah, within 2 or 3 minutes you will get everything. Okay, so don't worry. Just try to focus here. So what are the you can say data structures? First is available. Next is max. Max is a 2D array of n cross m. Okay, so for example, we might have say A, B, C. There are three types of resources. Okay, and let us suppose max means maximum requirement. Say the total we have say P naught, P1, P2, P3, P4. Total 5 processes are there. So roughly I'm writing 8, 5, 4, 6, 2, 3. Okay, 4, 4, 3, 2, 1, 4, and 6, 5, 2. Okay, roughly I'm writing the values. So for example, I will say P naught need 8 instances of A for completion. P naught need maximum of 5 instances of B for completion. P naught need maximum of 4 instances of C to complete. ऐसे ही same way you can say 1. P3 need 1 instance of B. P4 need maximum 5 instances of B and so on. That is the maximum. So this is the maximum requirement of each and every process, which we will write it in the form of 2D array type. I hope you have got it. This is 2D array in a table format. Okay. Take the snapshot. I will jump to the next slide. Next is allocation. Allocation is also 2D array of n cross m. Okay, and same we will say A, B, C. Here we have P0, P1, P2, P3, P4. So I am assuming 5, 1, 1, 2, 1, 2, 1, 1, 1, 1, 0, 0, 0, 1, 0. So this means these are the currently allocated to the processes. So P0 is currently having 5 instances of A. P0 is having 1 instance of B and 1 instance of C. Similarly, P1 is having 2 instances of A, 1 instances of B, 2 instances of C, and so on. This is the current allocation. So this matrix will give us idea about how many resource of which type is given to which process. Okay, this is the matrix. This is allocation. Okay, next data structure is need. Need matrix. Need is also n cross m. So I will say A, B, C, P0, P1, P2, P3, P4. Okay, so now you can see maximum requirement of P0 for A was 8, and here 5 is allocated. Please see this. P0 need 8 instances of a maximum, and it has allocated 5. So how many are left out, or what is the need? Need of P0? Need is 3. Okay, so 8 minus 5 is 3. For B check, P0 maximum requirement is 5, and here allocated it 1. So 4. Okay, just like that you can fill it. So let me fill just one row. So P0 maximum requirement for C is 4. See this. Maximum requirement of C is 4 and 1 is allocated. So 3 are left. So that's how we will write 3, 4, 3. Now I think you have got the idea. So I'm just directly filling the values. Okay, you can check it out yourself. 3, 3, 2, 1, 1, 4, and 6, 4, 2. So randomly I will check. Say P3 requirement B is 1. So how we will say P3 maximum requirement of B is 1. And how many are allocated? 0 is allocated. That means nothing is allocated. So obviously 1 is left. Need is 1. So I hope you have got it. This is the need matrix. So need, how we have calculated need? Need is nothing but max minus allocation. It is very obvious now. Maximum requirement we have, allocation we have done some allocation. So what is the need? Need will be what? Maximum minus allocation. That's it. So we have calculated this need matrix. Okay. Yeah. And the last is you can say requirement matrix. Okay. Fifth is requirement M. It is also 1D array. Okay, so now since this is M means number of resources whatever is available with us. So M value is 3 because there are 3 resources A, B, and C which are available with us 10, 5, and 7. I have assumed this now. So with A 10 instances are there, B 5, and C 7. Okay, so what is this requirement matrix? Requirement matrix will give us idea. For example, say P naught need one instance of A, so you will not say 1, you will say 1 0 0 like this. This is the requirement array. Okay, that means P naught need one instance of A and B and C 0 0 instances, so you will write like this. Okay, you will not write 1, you will write 1 0 0. That means for each and every you can say resource, you have to fill the value. Okay, so this is the requirement of P naught, whatever it has given just now. So P naught wants this, so it will write like this. Similarly, if I say P2 want two instances of B, so it will write like this. Okay, 0 2 0. That means 0 instances of A, 2 instances of B, and 0 instances of C. So I hope you have got it. So request is 1D array. So directly, indirectly, I want to say that each and every process will give request in the form of 1D array. So if, for example, P3 wants, say only the one instance of C, so it will not send request as 1. It will send request as 0 0 1. Okay, that means A it wants 0, B it wants 0, and C want one instance. Okay, so I hope you have got the point. So each and every process will request in the form of 1D array. Okay. Each and every process will give request in 1D array form. Okay. So this is request 1D array. So if we revise fastly, what we will say, first data structure is available. That means how many instances of how many resources are available with us, that is available. Next is maximum. So each and every process maximum requirement is given like this. And then allocation, how many resources of each type are allocated to each and every process, that is allocation matrix. And then need will be calculated by maximum minus allocation. That means what is the present need of the process. And if it want to request some resource, then it will send request in this format. Okay, so if even it wants C1 resource, P3 want only one instance of C, so it will give request as 0 0 1. Okay, so I hope you have got it. So these are the basic you can say data structures used, and now I will jump to the algorithm. Take the snapshot. Okay, so now we will start the basic algorithm. So what it is saying is, so I will take the previous example only. For example, A instances total 10 are available with us, B 5 are available, and C 7 instances are available. Okay, and I will give now matrices max matrix. So P0, I'm assuming there are total 5 processes, P0, P1, P2, P3, and P4. Okay, what is the maximum requirement of for each process A, B, and C? Three processes are, sorry, three resources are there, na? A, B, and C, and 5 processes are there. So each resource, how many instances are required, that is given by max matrix. So we will write say 7 5 3 3 2 2 9 0 2 2 2 2 and 4 3 3. This is the max matrix. Okay. Next is allocation matrix. Allocation matrix will be like this only. So how many are allocated? Okay, so for example, we say 0 1 0 2 0 0 3 0 2 2 1 1 0 0 2. So these are currently allocated. Okay, so now from this max and allocation, you can calculate need. Okay, what is the need? So P naught, see this maximum A needed is 7 and allocated is 0. So 7 minus 0, that is 7 is the need. Okay, and B5 are allocated, sorry, 5 are the maximum need and allocated it 1. So 4 is needed. And P naught want 3 instances of C maximum and allocated is 0. So it need 3. Okay, so like that we can calculate. So 3 minus 2 will be 1 2 minus 0 will be 2, 2 minus 0 will be 2. Next, 9 minus 3 is 6, 0 minus 0 is 0, 2 minus 2 is 0. Next is 2 minus 2, 0, 2 minus 1, 1, 2 minus 1, 1. Next is 4, 3, 1. I hope you have got it. So this is the need. Okay, and now we will calculate the available array. Okay, available means currently what are available. So A, B, and C, there are three resource types. So how many are available? So I will calculate from here. See this total allocated. Forget about processes. I will say totally allocated are 3 to 5 plus 2, 7. Total 7 instances of A are allocated. So out of 7, so 2 are allocated to P1, 3 to P2, and 2 to P3. So finally 7 are allocated, and total A are 10. So that means 3 are currently available with us. Similarly, allocated B is 2, 1 plus 1, 2, and 5. So 3 are available. Similarly, here 5 will be there. Okay. And 5 are allocated, and total 7 was there. So 2. So available is 3, 3, 2. So I hope you have got it. So questions will be asked in every competitive exam like this only. So they will give some processes, they will give maximum and then allocate it, and you have to calculate need, and then you have to calculate the available. Okay, and then I will say that some process demands something. For example, P1. Okay, or you can say P1 for example has demanded 102. That means P1 has demanded one instance of A, 0 instances of B, and 2 instances of C. So now how this algorithm will work, I will tell you that. Okay, so you can take the snapshot. I will jump to the next slide and I will show you the algorithm. Okay, yeah, so I hope you have taken it. So algorithm, how this banker's algorithm look like. Step number 1. Step number 1 is you have to match whether the request I is less than or equal to need I. Okay, request I is less than or equal to need I. If yes, then we will go to step 2, and else error. Okay, if yes, go to step 2, else error. What do you think what this step means? Request I should be less than need I na. For example, P1 has requested this, so this request must be less than or equal to need. For example, P1 has demanded one instance of A, okay, 0 instances of B, and 2 instances of C. So its request is, you can say, whatever he has demanded, that is correct. Okay, so because request is less than or equal to need, and individually you have to check. Okay, for example, if I say P1 has demanded say 315, is this okay? No, it cannot demand 315. Why? Because P1 need is just 1. How it has demanded 3? It is not allowed. Okay, so that's why we will simply cross it. So correspondingly you have to match, each and every number should be less than or equal to. Okay, so that means if P1 demand 1, 2, 3, then also it's not correct. Why? 1 and 1 are okay, 2 and 2 is okay, but how it has demanded 3 instances of C? Because it need only 2. So I hope you have got it. So these are all wrong, but currently whatever we have taken is 102. It is perfectly fine. So we can that means step number 1 is perfectly okay. Request I is less than or equal to need I. Okay, so whatever he or whatever the process has demanded, that is okay. Next we will go to step number 2. Now in step number 2 we will check if this request I is less than or equal to available. Okay, so the very first is, you can imagine like this, like the very first is in terms of banking, I will say process has demanded some money. Okay, so first of all, bank will check whether whatever he is demanding is okay or not. For example, you have property of 20 lakhs and you are demanding loan of 40 lakhs. So it is not possible for the bank to give you. Okay, so they can give you loan against property of 20 lakhs only. So first is that. Okay, so step number 1 was this only. That means request I should be less than or equal to need I. Okay, now if it is fulfilled, then banking people will see, okay, your property is of 40 lakhs and you are demanding 40 lakhs only. I will say okay, but the bank will have to check whether this much money is available with us or not. That is your available. Okay, so P1 has demanded 102, so it will first check whether it is less than or equal to need or not. It is okay, yes, it is less than or equal to need. Second step will be this much resources should be available with us, na? So that's why we will check this. So 102 less than or equal to 332, yes. So we can fulfill the demand. So this is the step number 2. Request is less than or equal to available. Okay, so if it is yes, then we will go to step 3. Otherwise, what we have to wait? If yes, go to step 3. Else you will wait. Okay, in the first step we have given error because we bank cannot afford this kind of thing. You are having just 20 lakh property and you are demanding 40 lakh. That means you are it is not valid. So that's why we have given error. Okay, so and in the next step we are saying that your request is okay, but available is less. That means bank is saying that your request is okay. You are demanding 40 lakhs loan, but I'm not having 40 lakhs, so you have to wait. That's why we are saying we have to wait. Okay, so if request is less than or equal to available, if it is yes, then we will go to step 3. Otherwise, we have to wait. Okay, so now we will go to step number 3. In step number 3, we will start doing reductions. So what we are going to do is, so see this. First was whatever he has demanded is okay. Second was money is available. Then what we will do, we will now do deductions. That means what? Available will become available minus request. So now our new available will be what? Let me write it. In step number 3, we will say available is equal to available minus request. Okay, that means 332 minus 102. So now our new available a new I will write 3 minus 1, that is 2, 3 minus 3, 3 minus 0 is 3, and 0 2 3 0. So this is new available. Are you getting it? Because now see this, you have given the loan. This is money which you are having, and somebody has demanded the loan. So currently, whatever money you are having, that will be what? This minus this. So we have done it. So new available we will calculate. Okay. So available is equal to available minus request I. Okay. And next will be obviously need will be decreased. Need I is equal to need I minus request I. Okay, so need will be decreased. So need is 122 and now it has demanded 102. Since 102 you have given, so your need will be less now. It will become 0. 2 minus 0 is 2 only, and it will become 0. So 020 will be our new need for P1. Okay, so that is what we have written here. And third step will be what? Your allocation obviously will increase now, because initially 200 was available, was allocated to you, but now 102 is now available, or 102 is now given to you. So it they have been allocated. So 2 plus 1, that is it will become 3, and it will become 2. It is just common sense, nothing more than that. Okay, very simple scenario. So let me revise okay, let me write it first. So the third point will be allocation I, that is equal to allocation I plus request I. Okay, so these are the 3 steps which we need to follow. So and now let me revise you so that you get more clarity. So what is the step number 1? First step is you have to check whether the need is okay or not. So first of all, this 102 will be matched with 122. Yes, need is okay. Next we will check whether these much whatever it has requested, that is available with us or not. If it is not available, then we have to wait. Otherwise we will say okay, just give it. Okay, and giving means what? Available will change now. It will become this available minus request. Need will change now because you have given these resources, so need will be decreased, and allocation will increase, so this thing will be added with allocation. Okay, so these are the basic 3 steps. Okay, and first step will give us direct error message. Why it will give direct error message? If because if request is not less than or equal to need, that means what? You are demanding more and you need less, so it is not allowed, so you will simply give error. So I hope you have got it. These are 3 step. And last step number 4 is you will have to check whether state is safe or not. After doing all this, check state is safe or not. This is step number 4. So let me do that also. So for step number 4, what we will say, this is new allocations. Now from these new allocations, You should be able to fulfill needs of processes. If you are able to do it, then state is safe, otherwise it is unsafe. So let me give you the idea. So available is this now. So first of all, I will try to fulfill P1. P1 needs 7 instances of A, but available is only 2. So P1 cannot be fulfilled. Next, we will check for P2. P2 can be fulfilled as 0 instances of A, 2 instances of B, 0 instances of C. Yes, it can be fulfilled. Now, since it can be fulfilled, that means P1, if P1 need is this, if P1 is given or if P1 need is fulfilled by this available, then obviously whatever is allocated to P1, that will be deallocated. So directly, indirectly, I will simply say P2 need is fulfilled. So now our available will become 3, because whatever is allocated, that will be given back now. See this P1 to P1 we have allocated 3 instances of A, okay, and 0 instances of B and 2 instances of C, and its need was 0 to 0. That means 2 instances of B is need. So the moment it get 2 instances of B, it will be completed. When P1 is completed, so whatever it has allocated, it will be deallocated. So directly, indirectly, I will say that this 302 will be added with this. So what we will get now, 5, 3, 2. Are you getting it? 2 plus 3, that is 5. 3 plus 0, that is 3. 2 plus 0, that is 2. 5, 3, 2 is our new available. So whatever it was having, it has just, you can say, given back. Next, we will try to fulfill this. Now available new is this. So we will try to fulfill P3. P3 need is 600. We cannot fulfill it. Okay, so P3 cannot be fulfilled. Then we will check P4. P4 need is 011, and obviously we have this 532, so it need can be fulfilled. So P4, whatever is allocated to P4, that will be deallocated. So I will say P4 is over, and 2 instances of A is allocated. So 5 plus 2, that is 7. This 5 and this 2 7, then 4, and then 3. I hope you got it. 3 plus 1 4, 2 plus 1 3. So 743. And what about my P5 now? Now new available is this. So P5. P5 need can be fulfilled. 431. Yes, obviously it can be fulfilled by this. So whatever is allocated, that will be deallocated. So 7, 4, and 5. So 5. Only 2 is increased now. So it will become 5. 7, 4, 5. Okay. Okay, so now new available is this. So the two were left out, P1 and P3. So we will try to fulfill that also. P1 was 743, and here we have 745. So obviously it can be fulfilled, and whatever is allocated, that will be freed. B1, so 755. Okay, next is P3. Yes, P3 now can be fulfilled. 600 was the need, and here we have 755. So whatever it was having, it will be given back. So we will get 10, 5, and 7. Okay, and I think you have got it. So what is the safe sequence? They will ask like this also. So presently I will say that state is safe. So since state is safe, so whatever we have done these calculations and all, that will be perfectly fine. Okay, and our new available will be this only 230 and so on. Otherwise we will undo all the changes. Okay, so state is safe or not? Yes, state is safe, because we can fulfill the demand of each and every process. So what is the safe sequence? They will ask this also. Safe sequence. Safe sequence will be P2, P4, P5, P1, and P3. P2, P4, P5, P1, P3. Okay, so I hope you have got it. This is the safe sequence. Okay, so this is the safe sequence for the processes. So hence state is safe, and that means deadlock will not occur. So let me tell you that also. If state is safe, if state is safe, then no deadlock. Okay, but if state is unsafe, then deadlock may or may not occur. Deadlock may or may not occur. Okay, so you should remember these points. So if state is safe, then deadlock will never occur. But if state is unsafe, then deadlock may or may not occur. What is unsafe state? Don't worry, I will tell you about that also. Okay, so since state is safe, so we will definitely get safe sequence. This is safe sequence, and this is one of the safe sequence. We can get many safe sequences. Okay. Yeah. So state unsafe means deadlock may or may not occur. But if state is safe, then deadlock will never occur. That is the basic point. Okay. So I hope you have got it. Take the snapshot. I will jump to the next slide now. Hmm. Okay, so now on this state of the processes, I will say I will try to give some other demand. I will try to fulfill some other demand. Okay, so for example, P naught has requested for 020. Okay, let me do that. Okay, take the snapshot of this. I will jump to the next slide. Done. Okay. Yeah, actually on the next slide, if we do, then it will create problem. So we will try to do it here itself. And I will take another color. Now let us suppose P2 has demanded 020. Now we will try to fulfill it, whether it is we can give it or not. Okay, sorry, P naught has demanded 020. So first of all, we will check whether this P naught need is okay or not. So P naught is 020 and it needs 743. So obviously it need is more. Okay, correspondingly, you have to check. Even if one of them is not fulfilled, you will say no, need is not correct. Okay, so so for example, P naught gave request as 050. So 050 is not good request. Why? Because it need only 4 instances of B, but you are demanding 5, so it is not valid. So anyhow, we have demanded only 2 instances of B, and its need is okay. So now we will try to fulfill the request. Okay. So step number 1 is over. Need is okay. Now available. Available new is this because just now we have allocated uh, 102 to P1. Okay. So after that, our new available is 230. So now we will try to see whether this 230 can fulfill this. Yes, of course it can do it because it has demanded 2 instances of B and 3 instances are available with us. So banking are saying, first of all, they are checking whether need is okay or not. Yes, need is okay. Now they are checking we have enough money or not. Yes, we have enough money also. So then we will start allocation. Okay, so how we will do allocation? See this, see the slide. And available is equal to available minus request. So this available will be decreased. So our new available will be what? 210. Okay, this is our new available 210. Okay, next what they are saying is need minus request. So our new need will become what? 020. So you have given, so it will become 2. Okay, and allocation will increase. So 2, so it will become 3. Okay, yes. So now we are going to check whether state is safe or not. So how we will do it? So we will try to fulfill. So our new available is this 210. So now please check from this 210 how many processes can be fulfilled or how or what are the sequence of processes which can be fulfilled. So first of all, we will try to check for P naught. P naught can be fulfilled or not? No, because it needs 723 and here we are having just 210. No, it cannot be fulfilled. Next, 020. No, we cannot fulfill it because here we have 1 and here it need 2. We cannot do 600. No, 011. No, because it need 1 instance of C but 0 is available. Entire need should be fulfilled. We cannot do it. 431. No, we cannot do it. So finally what we will say, P naught we cannot fulfill, P1 we cannot, P2 we cannot, P3 we cannot, and P4 we cannot. So this means what? State is unsafe. State is unsafe because there is no proper sequence in which we can complete the processes. State is unsafe. Now, since state is unsafe, so we will say that uh, deadlock might occur. I have just told you if state is unsafe, deadlock might occur. So whatever allocations you have done, you will simply deallocate it. Okay, so we will get back. So I will change the algorithm now. So what I have told you, check state is safe or not. If state is safe, then everything will be okay. But if state is unsafe, let me write it. If state is safe, then these allocations will be permanent. Then allocation will be permanent. And if state is unsafe, then roll back all the changes. Okay. So whatever changes you have made, you have to roll back all of them. So whatever changes we have made, we will try to roll back. Rollback means our new available will be this. that means the old one. Okay, and now this 2 will be, you can say, deallocated. Okay, now this 3 will be gone. Yes, so finally we will have just one only. Okay, so this is our, so we have just rolled back all the changes. So this is all about Banker's algorithm, and I hope you have got the point how we are going to do it. So the key points here are, in whatever question they will give you these things. Okay, max and allocation, they will give just two things, and they will give how many are available. So from that you will calculate the need, that is max minus allocation. Then you will get new available. How you will get available? Total 10 instances are there, and how many are allocated. So from that you will calculate 10 minus 7 is 3, and so on. Finally we will get available, and then process will for process we will have a request metric, request array. So process will request some resources, and then what we have to do, step number 1 is we have to check whether its need is okay or not. 102 it has requested, so request will should be less than or equal to need. If this is fulfilled, then we will check whether we have such that money also in our bank or not. If money is also available, then we will do the allocations, and these are allocations will be temporary. Okay, and if state is coming to be safe, that means we have a safe sequence. We will say these allocations will become permanent. Otherwise we have to roll back all the changes whatever we have made. So I hope you have got it. After making changes, we will check whether state is safe or not. So I hope you have got it. So I will tell you few more examples so that you get more clarity. Okay, take the snapshot. I will jump to the next slide. Yes, done. Okay. Yeah, and one more thing, you take snapshot of this also algorithm. Okay. So now I will solve a very simple question. So let us suppose a system contain 10 unit of same resource. We have only one resource A for which 10 instances are available. Okay, and they are giving three processes P, Q, and R. Okay, and they are giving max requirement, current allocation. Maximum requirement is 875. Current allocation is 413. Okay, and they are saying three requests. So first is P make a request of 2 units. P make request of 2 units. Second, Q make request of 2 units. R make request of 2 units. So now they are saying is, for safe state, which of these requirement can be fulfilled? Okay. For safe state, which of the following requirements can be fulfilled? Okay, that is what we have to check. So whatever we have studied, we will try to do that in the same format. So earlier we have given three instances, three resources A, B, and C, but now here only one resource is there, that is A. No problem, that is very easy task now. Okay, yeah, so there are three processes P, Q, and R. So whatever we have studied, this is a table which is given to you in your exam. It is a UGC Net question, by the way. Okay. So they have made this table like this, but we will try to make it in our own way, whatever we have studied. So we will make this P, Q, and R. Okay, and there is only one resource. So max, location, and need. Max is what? 875. Allocation is what? 413. And need we will calculate. So 8 minus 4, that is 4. 7 minus 1, that is 6. 5 minus 3, that is 2. So we have calculated need. And what is available? How you will calculate available? So allocation, current allocation C, 4 plus 3, 7 plus 1, 8, 8. And 10 are available, and total 8 have been allocated. So how many are available now? Current available is 2. Okay, yeah. Now check which requirement can be fulfilled. So if P has made request for 2 instances, whether you will give it or not. So if I give P 2 instances, so that means what? First of all, we will check the need. P request is 2 and need is 4. Its need is 4. So obviously its need is okay. Next is we will check whether that money is available. Yes, available also. It has demanded and two are available. We can do it. So we will try to do it. Okay. So what we will do? So available will be decreased by this request. That means 2 minus 2, that is 0. Need will be decreased. That means it will become 2. Okay. And allocation, it will increase. That means it will become 6. Now we will try to check whether state is safe or not. So see, this available is 0 and every process need either 2, 6 and 2. So none of them can be fulfilled. So there will be a deadlock. Okay. Rather, I should more precisely, I should say state is not safe. Okay. Not safe. So P is equal to 2. We will not give. So take the snapshot. Then so I will undo all the changes. So P2 I cannot give. Next is Q has demanded 2. So let me check that Q. First of all, need okay. It need 2, 6 and it has demanded just 2. It is okay. Next available, yes, okay. Then we will try to do the, you can say allocations. So available will be decreased by 2. That means it will become 0. Need will become 4 because it will be decreased by 2 and allocation will increase by 2. That means it will become 3. Now we will try to check whether state is safe or not. No, it is still unsafe. Why? Because available is 0 and they need 4, 4 and 2. So obviously state is unsafe. So Q has demanded 2, it will be rejected. Okay. So it will be rejected. Next is R has demanded 2 instances. So for same, first of all, we will check whether need is less than or equal to it. Yes. So 2 is less than or equal to 2. Yes. Available. Yes. Money is also available with us. So now we will try to do allocations. So for allocations, what we will say, available will be decreased by 2. Need will be decreased by 2 and allocation will increase by 2. Okay, yeah. So finally we have got it. So now we will check. Oops, it will become 0. Na? Available will become 0. Decreased by 2, so it will become 0. Need will be decreased by 2, so it will become 0. And allocation, it will be increased by 2. That means it will become 5. Now we are going to check whether the state is safe or not. So R requirement is 0. See this, R requirement is 0 and available is also 0. So that means we can fulfill it. So R, whatever is allocated to R, that will be deallocated. So for example, this 5 is allocated now. So this 5 will be deallocated. So let me do it. In sequence, if we try to do P need 4 instances, but 0 is available. So P cannot be fulfilled. Q requirement is need is 6 and available is 0, so it cannot be fulfilled. R requirement or need is 0 and available is also 0, so we can do it. So whatever is allocated to R, it will be deallocated. That means 5 will be left. Okay, because now R is over. Now we will try to check P need is 4 and 5 are available. It will be also fulfilled. So whatever is allocated to P, that will be deallocated. It will become 9. And then Q can be fulfilled. Yes, Q needs 6 and 9 are available. Yes, we can do it also. Whatever is allocated, that will be deallocated, so we will get 10. Okay, so RPQ, that is the safe sequence. So since we have got safe sequence, so the state is safe. So for state safe, which of the following can be fulfilled? Only third requirement can be fulfilled. That means if R has demanded 2, P and Q demand of 2 will not be fulfilled. Okay, so I hope you have got it. So these are very simple questions which have been asked in other competitive exams. Okay, so it is very easy now. I hope you have got it. Okay. Hmm. So let me solve another question. It is similar to this question. Take the snapshot. I will jump to the next slide. Done. Okay. So now let us suppose see there are say three processes P1, P2, and P3. Okay, let us suppose we are having three processes P1, P2, and P3. Okay, and there are three resources X, Y, and Z. So maximum requirement is 843, 620, 333. Okay, next is allocation. Allocation of X, Y, Z, that is 001, 320, 211. Okay, and available is also given to you. So they will try to twist the question. Okay, available is 322. Okay, and now they are saying request number 1, that is P naught has requested 2 instances of Z, that means 002. So whether it can be fulfilled or not, we have to check. So it is very simple. I will say P naught has requested 002. So first of all, we have to check the need. Okay, so we have to calculate the need. So X, Y, Z. Please tell me the need. Max minus allocation 8, 4, 2. I hope you have got it. 8 minus 0, 4 minus 0, 3 minus 1. Next will be 3. 6 minus 3, that is 3. 2 minus 2, that is 0. And 0 minus 0 is 0. Next will be 3 minus 2, it is 1. 3 minus 1, it is 2. And 3 minus 1, it is 2. So this is the need. So now request number 1 is P naught has demanded 002. So this is for okay. I think I have okay, P1 I think so. It should be the P1, na? P naught is not there, na? P1 has demanded 002. Request number 1 is P1 has demanded 002. So whether it can be fulfilled or not. So I will simply check. Need is 842. P1 need is, see this. This is P1, this is P2, this is P3. Need I have just calculated max minus allocation. So now P1 has demanded 002 and P1 need is 842. Yes, everything is fulfilled now. 0 is less than 8, 0 is less than equal to 8, next 0 is less than equal to 4, and then 2 is less than equal to 2. Yes, so everything is fulfilled. Okay, it's good. Need is okay. Next we will check available. So 3 to 2 is available and it has demanded 2. So yes, available also we have. So now we will try to do allocations. Okay, and these are allocations will be temporary. And when it will become permanent, if we try to get state is safe. If state is safe, then we will say it's okay. Otherwise, we will say no, not okay. We will roll back all the changes. Okay, so let me do it. So a request is this. P1 has requested it. So first of all, available will be decreased. So our new available will be 320. Okay, because 2 has been given. 2 instances of set has been given. So allocation, it will be increased by 2. It will become 3. And need, it will be decreased by 2. It will become 0. So I hope you have got it. So now our new available is 320. From this 320, see which processes can be completed. Let me write it. Available new is 320. So from that, which process can be fulfilled? P1. No, P1 cannot be fulfilled. Yes, P2 can be fulfilled. Now, if P2 can be fulfilled, so I will write it P1 cannot be fulfilled, P2 can be fulfilled. So whatever P2 is having, that will be deallocated. P2 is having 320, so it will be deallocated. So what we will get, 3 plus 3, that is 6, 2 plus 2, that is 4. So 640, that is our new available with us. Then we will try to fulfill P3. P3 need is 122. Yes, we can fulfill 122. Yeah, sorry, we cannot fulfill 122 because for Z we need 2 instances, but here only 0 instances of Z is available. So P3 cannot be fulfilled. Okay, now we will try to check again P1. P1 can be fulfilled or not. So P1 need is 842 and here we have 640, so it cannot be fulfilled. So indirectly what I will say, P1, whatever P1 has demanded 002, it cannot be fulfilled. Okay, so I hope you have got it. So we are not getting safe state. So we will say this request will not be granted. So we will roll back all the changes. Rollback means we will get this same result. Okay. Yeah. Okay. So this is our same state we have got. Okay. And next we will imagine whether P1 has requested. Okay, P1 earlier it has requested 002. Now it has requested 200. Now check whether it can be fulfilled or not. Okay, so first of all we will check P1 200 and its need is more. Okay, then available, yes, we have available also. Then what we will say, we will try to do allocation. So 200. So here it will become 1. Let me write it new available. A new will be 122. Okay. Yeah. And now from that, we will try to see which process need can be fulfilled now. P1 cannot be fulfilled, P2 cannot be fulfilled, but P3 can be fulfilled. 1, 2, 2. P3 can be fulfilled. The moment P3 is fulfilled, so all, whatever it has allocated, it will be deallocated. So what we will get 3, 3, and 3. Okay, 2 plus 1, that is 3. 1 plus 2, that is 3. 1 plus 2, that is 3. So 3, 3, 3 we will get. So now from this 3, 3, 3, which process now can be fulfilled? Obviously P2. See, P1 cannot be fulfilled again because P1 need 842 and it is not available. P2 can be fulfilled, yes. P2 need 300 and 333 is available, so it will be you can say fulfilled, and whatever it has allocated, it will be deallocated. So P2 will be fulfilled, and finally what we will get, 3 plus 3, that is 6, 3 plus 2, that is 5, and 3, 6, 5, 3 we will get. Okay, and now we will try to fulfill P1. So P1 need is 842. Okay, 842. So obviously it cannot be fulfilled from this 842. Okay, so again state is unsafe, so we will roll back all the changes. Okay, so I hope you have got it. So this is the way to solve the questions. Okay. Mm. And one more type of question is coming to my mind, that is also very simple. Let me solve that also. So for example, say we are having P1, P2, P3, P4. Okay, 4 processes are there, and the max requirement is 11213, 222, 10, 21311, 11220. Next is allocated. Allocated is 10211, 20110, 11011. 4 times 1 and 0. So there are total 5 processes, 5 resources. Okay, A, B, C, D, and E. You can label them A, B, C, D, and 5 resources. 5 resources. Yes. Okay, and these are the 4 processes. Max allocation is given to you. Okay, and they are saying available. Available is 00x11. Okay, so they want us to find minimum value of x. Find minimum value of x so that state is safe. Okay, so that state is safe. So find the minimum value of x. Yeah, so how we will do it? So as we have studied, we will first find the need. Need will be what? 1 minus 1, 0, max minus allocation. Now, so 1 minus 0 is 1, 0, 0, 2. Next it will be 0, 2, 1, 0, 0. Next, max minus allocation I am doing just 1, then 0, then 3, then 0, then 0. And 0, 0, 2 minus 1, that is 1, 1, and 0. Okay, this is the need. So now what we are having, 0, 0, x double 1. Okay, so we have to find the minimum value of x so that the state becomes safe. So if you want to get safe state, so what we want is so this available should be able to fulfill need of any process, and step by step we are able to solve each and every process or need. Okay, we are able to fulfill each and every process need. So what we are going to do is, so see this 1 and 1 is okay. These two are zeros. Okay, so now try to fulfill which process need can be fulfilled. So these 3 cannot be fulfilled. Okay, because first 2 are not 0. So what is left? Only this last process is left out. Okay. So what we want is, so 00. Okay, and here we have x, and here we have 1, and here also we have 1. So this can be fulfilled. So minimum value of x, if we take it to be 1, so what we will get, 00111. Now from 00111, this P4 request can be fulfilled. P4 request can be fulfilled, and whatever is allocated to it, that will be taken back. So finally our new available will be what? 1, 1, 2, 2, 1. Are you getting it? I'm just adding. Allocation is added with this. So we will get double 1, double 2, 1. Now from this double 1, double 2, 1, which process need can be fulfilled now? P1. P1 need, see this, P1 need can be, no, P1 need cannot be fulfilled. Why? Because available 1 and here we need 2. So P1 cannot be fulfilled. Now P2 can be fulfilled? No, because here we have 2 and here we have 1. P3 can be fulfilled? No, because here it is 3 and here it is 2. So now we cannot fulfill it. So what should be the other way? If I take in place of 1, if I take x to be 2, so now what will be this value now? If so it will become 2 here. So whenever we are going to add, what we will get 1, 1. So it will become 3. I hope you have got it. Na allocation was here 1, so 1 will be added with it, so it will become 3. Na so double 1 3 1 1, double 1 3 1 1. I think. Oh sorry, double double 1 3 2 1. Yes, double 1 3 2 1 we will get. Okay. Now see which process need can be fulfilled. So now P3 can be fulfilled easily. Okay, P3 can be fulfilled easily. Why? Because you can check it out correspondingly. Double 1 3 2 1, and here we need 1 0 3 0 0. Yes, it can be fulfilled. So whatever is allocated, that will be taken back. Double 1 0 double 1. So we will add it. So we will get 2 2 3 3 2. I think you have got it, na? So we have just added this and this P3 allocation, and this we have added. So double 2 double 3 2 we have got it. So P3 is fulfilled. Now please check which we can fulfill. So P2 can be fulfilled. Yes, P2 can be fulfilled. So P2 will be fulfilled. Individually you have to check. See this. P available is this, and P2 need is this 0 2 1 double 0. Yes, it can be fulfilled. So whatever is allocated, that will be taken back. So we will get 4. 2 plus 2, that is 4. Then 2. Then 4. Then 4. And then 2. P2 is over. Now we can fulfill P1 obviously. Okay, P1 is 0 1 0 0 2. Obviously it can be fulfilled. So what we will get 1 0. So okay, so we will add it now. So 2 4 plus 1, that is 5. Then 2, then 6, then 5, and then 3. Yes, so every process is now fulfilled. So finally minimum value of x should be 2. I hope you have got the point. Okay, so this was the most tough example which we have solved. If you have got this example, that means you have crystal clarity about Banker's algorithm. Okay, so very simple. And one more thing, I have just solved it in a random way, safe sequence. It is not that we will get, if state is safe, then we can get multiple safe sequences also. Okay, for example, after fulfilling P4, we have fulfilled P3. After fulfilling P3, we can fulfill P1 also. But I have tried to fulfill P2 first. Okay, so P4, P3, P1, P2 can be one of the safe sequence. And P4, P3, P2, P1 I have just given you. So if state is safe, we can have multiple safe sequences also. Very, very important point. Okay. If state is safe, then we can have multiple safe sequences also. Okay. So directly, indirectly, this question have been asked in GATE and Net also. That means if state is safe, then unique safe sequence is there or not? No. Unique safe sequence is not there. We might have we might get more than one safe sequence also. Okay. Hmm. So if state is safe, then we might get multiple safe sequences also. Okay. So that's it. So this is the way to solve these type of questions for on Banker's algorithm. Okay. Yeah, so that's it. So our now process management is over. We are not digging deep unnecessarily into the other topics. So in the next lecture, we will start memory management. Okay. Yeah, thank you so much. Bye bye.